Okay, so in example 1 here, we are asked what are the real and complex roots for the polynomial shown in the graph. We have its equation given right here, and then the graph below. So first, the real 0 is easy to find because you can see them on the graph. So we have one real 0 appears to be 2. So x equals 2 is a real 0. But we may have more roots. In fact, we have up to 3 roots if we count multiplicity. So we need to figure out what the other roots are. And we can't tell what they are looking at the graph. So I know that this one has to occur an odd number of times because it does go straight through. But the easiest way to figure out exactly what they are, especially if we're looking at complex roots now, is to use polynomial division to reduce the degree of our polynomial. So that's what I'm going to do. My first root is 2, so I'll use 2 to help me reduce the degree of the polynomial. My coefficients for my polynomial, starting with x to the third, is 1x to the third, negative 1x squared, negative 1x, and negative 2. We can use long division if we want. Synthetic division is just a lot quicker, because we may have to do this process multiple times, depending on the problem. So we'll drop the 1 down and just go through synthetic division. So 2 times 1 gives us 2. Multiply, then add. Negative 1 plus 2 is 1. Multiply, 2 times 1 is 2. Then add, negative 1 plus 2 is positive 1. Then multiply, 2 times 1 is 2. And then add, giving us 0. We know that this should be 0. The remainder should be 0 because I can clearly see that it is a root, which means it should go in evenly. So with that, we know we are down to 1x squared, reducing the degree by 1 after the division, plus 1x plus 1. Now with this, to figure out the remaining roots, we could either do factoring, try factoring, or use quadratic formula. Our goal here with synthetic division was to get it down to a quadratic. Once we have a quadratic, we have many strategies to handle it. But higher degrees, we don't. So we're going to go ahead and try factoring it. If I multiply my first and last, I'll have 1x squared. There are no combinations of factors of 1 that can add up to be 1. So we can't factor it, which means the remaining roots are either irrational or complex. So we're going to use quadratic formula to do this. So A is 1, B is 1, and C is also 1. So I will plug it into the quadratic formula, which is negative B plus or minus the square root B squared minus 4AC all over 2A, which I didn't actually put the A there. There we go. Now we need to simplify this, so we have negative 1 plus or minus. Underneath the radical, if we type it into the calculator, we'll have negative 3 over 2. We do need to simplify the radical here. We can't actually break down 3, but it is negative. So the square root of negative 1 is I. So we'll have negative 1 plus or minus I square roots of 3 over 2. And this gives us all 3 roots to add up to the degree. The first root is the 2 that we found earlier. The second and third roots is the negative 1 plus minus I square roots of 3 all over 2. Remember, the plus minus means that there are 2 separate answers. So overall, if I list them out, we have 2. We have negative 1 plus I radical 3 over 2. And negative 1 minus I radical 3 over 2. And there are all the roots for this polynomial. Okay, in this example, we're supposed to use the graph to help us write the function in factored form. First of all, we notice it is a fourth degree polynomial. So that means there should be up to 4 roots, including complex roots. So we're going to use the same approach as before. We're going to use synthetic division to help us reduce the power down to a quadratic. Once we have it as a quadratic, we can try our old factoring strategies for quadratics to see if we can break it down. As far as roots go, the ones that we can see one right here of -3. But it looks like because it is tangent at x equals -3, that occurs an even number of times. We have 2 other roots, which we can't tell exactly what they are, so we can't get the factored form just by looking at the graph. So we have a total of 4 roots. I see 2 that are probably irrational because they're touching the x-axis, but not whole numbers, and I can't make out fractions anyways just from the graph, so I'm going to just probably assume they're irrational. And then I have the one that is here that must occur at least 2, 4, 6, or 8 times. Because we need a total of 4 roots, I know that this one has to occur 2 times. So I'm just going to make a note, occurs twice. That's due to the multiplicity of the root. The multiplicity determines the shape on how it interacts with the x-axis. With that being known, I'm going to use the roots I do know, the -3, to reduce the degree of this polynomial. So -3 is my root. My coefficient, starting with x to the 4th, is 1x to the 4th, then 6x to the 3rd, then 7x squared, -12x, and then -18. As we do this, our remainder should be 0, because we do know that x equal to -3 is a root. -3 times 1 is -3. Add them. -3 times 3 is -9. -9 plus 7 is -2. -3 times -2 is +6. And +6 plus -12 is -6. -3 times -6 is +18. And then add on, we get the remainder of 0. I should probably mention this because I know some people ask this. You'll notice that we didn't switch the sign with the -3, and that's because when you are doing synthetic division, you want to use the root and not the actual expression that you're dividing by. So the root is what's used for synthetic, and that's why we did not change the sign, because -3 is the root. Okay, so we've done the synthetic division for the x equal to -3, but because of the multiplicity, because of how it interacts with the graph, I know it occurs twice. So I'm going to do synthetic division with -3 again. So I'm going to go ahead and bring my coefficients down. 1, 3, -2, and -6. We have -3. So we're going to do it again because, again, multiplicity of 2. 1 comes down, -3 times 1 is -3. 3 plus -3 is 0. -3 times 0 is 0. Add them, we get -2. -2 times -3 is +6. Add on, we get 0. Now we need to actually write out the variables. Originally, this was x to the 4th. So after doing the synthetic division the first time, we're going to have an x to the 3rd as the highest power. But then after doing synthetic division a second time, we'll have x squared as the highest power. So we have 1x squared plus 0x minus 2 as the remaining expression that we have. This is a quadratic, which means we can use approaches from earlier in the year to try to factor it. There's two terms, so first of all, just checking, there is no common monomial in the two terms. Next, because there's two terms, I would look for a pattern. And while the first term is a perfect square, the second term is not. So I can't use the a squared minus b squared pattern. And since there's not three terms and the pattern doesn't work, I can't actually factor this. So this itself is one of the factors. So overall, our factors are going to be x minus 2, or sorry, x squared minus 2. And then the other factor is going to come from the root that we had earlier, the x equals -3. But the factors and roots, remember, are opposites. So if x equals -3 is the root, then x plus 3 is the corresponding factor. So x plus 3. We know x plus 3 had a multiplicity of 2. So there we have it. And if we look at the factors, you can see that the total degree of all the roots, which should add up to be 4. We have this one twice, so that makes a degree of 2. And then we have the degree of the other one, which is another 2. Adding them up, we get 4. So there we have it.